Friction, a contact force. Friction is a force created when two surfaces move or try to move across each other. Friction always opposes the motion or the attempted motion of one surface across another surface, and that means that friction always tries to stop the direction of the motion. The strength of friction, the size of the force, depends on the texture of both the surfaces that are trying to move. There are different types of friction. Static friction is when there is no movement. Dynamic friction is when there is movement, and that can be sliding friction or rolling friction. Fluid friction is the description of friction as it moves through a fluid, and that could be a gas, which would be air resistance, or friction through liquids. In these pictures, we've got some images of different types of friction. So in the top picture, we're showing static friction. A box is positioned on a slope, so gravity is trying to move the box down the slope, but friction is opposing the movement and pushing in the opposite direction, and overall there is no motion. For sliding friction, gravity is acting on this slope, on this sled. Friction is opposing the movement, but it's not big enough to overcome the downwards force, so the object slides. Rolling friction is smaller than sliding friction because less contact is made between the two surfaces. These pictures show fluid friction. On the left, we have a car showing the aerodynamics of the wind as the air passes over the vehicle, and you can see how the lines show that there's been disturbance of the air on the back of the car. But the more streamlined a car is, then the faster it will be able to move through the air because there'll be less air resistance. And same for the swimmer. In water, a streamlined position will mean that there's less drag, and a non-streamlined position will result in more drag, so it'll be harder to move through the water. You have to put a greater force forwards on the water to move through. Here's another example. If you try to slide a book across the surface of your desk, then the desk will exert a friction force and oppose the movement. So you'll be very aware that if you have a smooth desk surface, the book will slide easier than if you have a rough desk surface. Without friction, we wouldn't be able to walk. Our feet would just slip backwards and forwards over the ground, and it'd be like trying to walk on ice. And this picture shows that it's the static friction, that moment that our foot is in contact with the ground is a moment of static friction opposing the forward slipping or the backward slipping of our shoe on the ground. So without friction, we wouldn't be able to walk. And with this picture, we can see a close-up of the intermolecular attractive forces between molecules on the different surfaces. When you've got a very smooth surface, then the intermolecular attractive forces are low. And when you have a rough surface, then it's like, in a molecular terms, moving one set of mountains against another. Friction generates heat. So as the two surfaces rub together, then we get heat produced. You can see that beautifully on the picture of the space capsule re-entering Earth's atmosphere, and the air rushing against the metal base of the space capsule has made it glow red hot. That's a disadvantage if you're trying to live inside that space capsule, so it has to be designed to withstand those high temperatures. But it can be of use if you're trying to set fire deliberately to something. So when you use a match, you make use of friction on the side of a matchbox. And when you're trying to light a fire with two sticks, you're using the friction and the heat that you generate from that to set fire to really dry bits of grass so that you can build a campfire. Friction has other consequences. So yes, it produces heat, it also wears away materials. And generally that's a bad thing. So we've got pictures here showing worn out shoes, worn out tires, blisters on the backs of our heels, and a set of worn out steps that have been stepped on for many, many years, and the sandstone's eventually worn away. So friction depends on the nature of the two surfaces and the degree to which they are pressed together. You can reduce friction. You can add lubrication like oil or graphite. You could change the type of friction. It's much easier to roll your suitcase along on wheels than it would be to drag it. You can make things more streamlined, and if you increase buoyancy and move the object up out of the water, you can reduce the friction so that you're trying to push through air rather than pushing through liquid. And that's one of the technologies they use to make advanced swimsuits, make the swimmer more buoyant and take them out of the thick water and into the thin air.